the absolute minimum value of G on the closed interval, bracket -4, 4, close bracket. That didn't sound right.
Justify your
Justify
answer.
your answer.
Thank you. So then, first of all, when we're looking at absolute minimum, we have to include the inbounds, right? So -4 is part of it, and 4 is part of it. So then looking at our PVA card, unless you have it memorized, if the there's a relative max, if the F is going from positive to negative, but then we're looking for what? Minimum. So instead of going from positive to negative, we're going from negative to positive. So let's find where we have the graph go changing from negative to positive. At this point, we're under and then we're over. So that means this right here is our relative minimum. So note that on the front, because I'm going to move this away. So we have a relative minimum also at 0. And there's nowhere else where it goes from negative to positive. So we're looking at testing 3 points. Now we have to defend as to why 0 is a relative minimum. Let's write our relative minimum at x equals 0 because g prime of x, which is also represented by f of x, is going from what sign to what sign? Negative to positive, not just changing sign. That could be anything. So then we make our chart, and we're comparing from g of x, and I'm going to write the formula on here so I don't have to flip back and forth. It was the integral from -4 to the x, f of t dt. We're plugging it in. So we have our 0 and our inbounds. Now g of 0, didn't we already find that on part A? Was 3 over 2. And then we have g of -4. That's the only one that you actually need work for. So when I plug it into this formula, it is -4. That's a negative in case that line took over. -4 to -4, f of t dt. Now, is there any movement if I start at -4 and I'm stuck on -4? No. So our movement really in the end is 0. And then we have g of 4 was part of part A, which was 11. So we know our absolute minimum is our smallest number. So between 3 over 2, 0, and 11, where's our minimum? Right here. So I'm going to actually phrase it exactly the way I see in the sentence. Absolute minimum value of g in the closed interval of -4 to 4. Let's copy that. The absolute minimum value of g on, and I'm just going to use a closed interval sign. You can be redundant if you want, is at g of -4 is equal to 0. So let's see how they're going to grade you. Reasoning why x equals 0 is part of our minimum is going to be 1 point. And plugging everything in and getting the correct y value is another point. And the whole sentence with the answer is 1 point. All right, let's move on to part C. Danielle, let's read.
Find all intervals on the graph of G are concave down. Give a reason for your answer.
Okay, so let's see. Concave down. Do y'all see we have concave down here? It is concave down when F is going or is decreasing. So let's go ahead and find the locations where it is decreasing. Where did my second paper go? All right. So it is decreasing. Right here is increasing. Would y'all agree this is going down? That's decreasing. Do we have another spot that's decreasing? From half to 1. And where else? From 2.5 to 4. So let's go ahead and write that down. So on here we have, and I'm going to put on here when g prime of x, which is represented by f of x, is decreasing. This is just my side note. If you write this and in your reasoning you don't reason it, they might be generous and give you 1 point for it. So let's write out, I'm going to underline what I'm going to write down. I'm going to start with that as a sentence stem. The graph Girls in the back, are we also working on this FRQ? Of G is concave down. On the interval, we have -2 to -1/2. Union, 1/2 to 1. Union, 2 1/2 to 4. You could say 2.5. And the reasoning is that G prime of X is doing what? It is decreasing. And do mention that you understand that the G prime of X is equivalent to F of X is decreasing. And there's 2 more points embedded on this one. The interval, all of it, it's all or none. 1 point. And your reasoning is another point.